How are you doing? We've got arms up, excellent. Good. Is the mic on? Ah, that's better. We've got a little bit of amplification going on. Good. Well, it seems to be quite a few of you still here. Hopefully a few new guys as well. Hope we all enjoyed the talk from Gree. And now we're going to try and take the discussion up a notch. What we're going to try and do now is look at the world of multiplayer. I have a certain history when it comes to multiplayer. A long time ago for BT, I used to run the online gaming service Wireplay. At 3, we launched with Synergenics the first-person multiplayer shoot-'em-up. Various successes and failures that followed. But today, we've got a couple of guys who are at the heart of what we're doing now. I know these guys for quite a while. Exozet Games have a fantastic platform, and Robert Boehm from Exozet Games is going to tell us a little bit more about the intricacies of real-time multiplayer, and representing the asynchronous side of games, so not necessarily real-time play, is Matthias Hellmund, whose Exozet company is responsible for Settlers of Catan and Carcassonne, and I'm sure he'll tell us a lot more about the joys of taking those experiences. So without further ado, I will pass you over to the multiplayer experts. Thank you.
Yeah, thanks for the kind introduction. A warm welcome to everyone. Thanks for coming here to our speech about synchronous versus asynchronous mobile gameplay. Quite hard to pronounce for me. I prefer actually saying multiplayer games like we said back in the day. But however, it's a hot topic currently, and it's getting more and more popular to build such games on mobile phones as well. And we are more than happy to be here and to share our knowledge and experience that we made in the past years building such games. So today we will first define the term, so what it is really what we are talking about, so we are all on the same page and know what we are talking about here, actually. So then we give you some insights about matchmaking, so what's important there, lobbies on mobiles. Talk a little bit about real-time challenges, and then we will try to bring everything up in case studies. So we have real-life examples of asynchronous and synchronous games up to real-time games. And last, we will have some special topics like communication stuff and timeout stuff. So lots of tricky things that are in this topic. So yeah, a little bit about myself. I'm Robert, founder and managing director of Playju. We're a studio for cross-platform multiplayer games and social games. And our first game actually is built on Exozet Games Photon technology, which is a great platform, a leading network engine for Unity, iOS, Android, Flash, Windows Phone 7, all that stuff, which gives us the ability to actually go cross-platform, which we are really happy about. And that's also my second role, to promote this technology as an evangelist. And I'm more happy than to do that. I have actually over 8 years experience in mobile multiplayer games, so I could say I'm a kind of dinosaur in that area, but that makes me feel so old, so I don't like it too much. Okay.
Yeah, thanks, Robert. I'm Matthias Hellmund from Exozet Games. I'm heading the mobile development department there, and I'm probably kind of the dinosaur in the mobile development area. And we are just moving into the multiplayer space right now with a couple of our titles. We probably specialize a bit in adaptations of mobile board games, such as Settlers of Catan and Carcassonne for different platforms. And I am also going to show you a bit of some case studies and some special topics inside around those products. But now let's get a bit political first, I guess.
Yeah. Let's define those terms. So synchronous versus asynchronous games, or it's like calling versus texting. I think it's pretty much put it to the point already. But going more to the game side, so synchronous games, what are these? It's simple. Players play together at the same time, like in a tennis game or in a strange game called chess boxing. So a mixture between real-time action and turn-based stuff. So on a more abstract level, it is you can consider simultaneous movement games or real-time games and turn-based games. They can be all synchronous, but they can also be
asynchronous.
Yeah.
Right. So what we see here is a photo I shot just this weekend at the Computerspiele Museum in Berlin. And that's an example of the classic correspondence chess that people were playing a couple of years ago, based on postcards sending to each other, detailing their move they're going to do next. So it's really a classical turn-based game, and a similar game mechanic is basically employed also in a couple of mobile games nowadays, and also PC and browser-based games, where basically the people do their turns independent of each other and just wait till the other player has done his turn. Right. So when we look at board games in particular, those turn-based games can basically be played in both ways. They could be played asynchronously, meaning that you basically can do something else while the other player does his turn, or you could also play them synchronously, meaning you also are able still to communicate with your counterpart, like Mr. Bush, for instance, and also have a kind of meta game or communication going on in parallel to the actual turn-based game. Right. So how do actually players players match together? How do they actually start such a game session? You basically can think about different ways to bring players together. The most obvious one is to play a custom game. So you basically decide you want to play a game now, and you invite your friends or your buddies to this particular game session. You can find your buddies through different channels. We'll come into that a bit later on, I think. Be it through social networks or through a specific game-specific buddy list. However, and especially in the mobile space, you also want to be able to join a match pretty quickly. Just when you have this 5 minutes of spare time, you want to jump into a multiplayer match right now. So that's what we call quick match. And it's really the question, which kind of algorithm do you employ in the background to match those players together appropriately so you don't just get any random opponent. So one way to do is to do a skill-based matching, probably based on an ELO ranking on some kind of leaderboard. Another and equally important aspect is to do a time-based matching as well. So if there's one player waiting for, let's say, 30 seconds already to find an opponent, it's probably a good idea to have your backend match this player in with some of the next players joining, even if their skill differs quite a lot, to not keep them waiting too long. Further down the road, you could also think about adding some special features such as blacklisting particular players who you just don't get along with in multiplayer matches probably. And you could also think about employing a couple of AI bots to jump in if no human player is able to join that particular session. Usually when starting a game, even an asynchronous multiplayer game, there's some kind of synchronous waiting state where all players joining the session come together initially to actually confirm that they want to join that particular game. And from then on, it can become asynchronous again, and people have the ability to wait and do something else while the other players do their turn.
Yeah, some words about matchmaking on mobiles or mobile lobby design. So I think it's really tough to have this old metaphor of lobbies that people know with long lists and so on and so forth. So my suggestion is keep it simple, definitely. So for me, a quick match should be always the first option. So there should be a big button, play now, and the users can just jump into the game. I think that's really important. Yeah, avoid these long open games lists where people click on and finding out that the game is already gone or already started. That really sucks, I think. Instead, you can use filters. So just I want to play on that map, but then play now, and the user jumps in a game and plays on his desired map. You should make things as transparent as possible. So you should show how many people online currently. If you have implemented skill value, which I would highly recommend, then you should show the skill values of the opponents, if possible. And really important, I think you should show a countdown until the game will start, so the user actually knows how long he has to wait until the game starts.
Besides, the countdown also gives you the opportunity to do some nice things in the background already, some work that just needs to be done and that can be hidden with this countdown.
Yeah, exactly. And I know many lobbies have this room metaphor with chat rooms, and you can chat a lot, and I don't think that works so well on mobile. So instead of, if you want to, you can use predefined messages, emoticons, or whatever, instead of free text chats. So now coming to a really favorite of mine, I call it the Holy Grail of synchronous games. Real-time multiplayer games are the Holy Grail, I think, because they are simply the king of complexity. I know it, I've been through it with my own game and with a couple of partners who worked together with Exozet Games on real-time games, on real-time multiplayer games. So you will have edge cases that you really drive you crazy, and you cannot avoid them, and you cannot predict them when you start building the game. But they will be there at a certain point, so be aware of it. And what you have to really accept that there's always a trade-off between technology, technological restrictions, and features you want to have implemented in a nice way. So you have to accept that there are trade-offs. I know that some companies are still working with these huge game design documents with like a couple of 100 pages, and they give it to their developers and say, hey, now build me this game. So that's not really the way. You should do it with synchronous games, or even with any multiplayer games. You should really have an intensive teamwork, because otherwise it's the best way to fail if you just try to throw over a game design document to your developers and say, now let's do it. So I cannot recommend doing that. Instead, use an iterative approach to build your game. Some personal message, if you consider make or buy. So get a quote by a team who really did something quite similar and compare that to all the cheap and offshore teams and your own calculation, and yeah, see what happens then. So it's quite interesting sometimes. I know that from my past experiences. So how do you then can handle that technology restrictions versus game design? So I think your team should have expertise in both technology and game design of synchronous games. If you do not have it at the start, you have to be willing to invest time to build up those experiences. So it's not impossible if you do not have it at the start, but it will definitely take longer then. So because you have to make some really, really important technological decisions at the beginning of the project, which will have a huge influence to the whole project afterwards, like the overall architecture. If you want to have a peer-to-peer architecture versus a client-server architecture, what protocols will you use? What is and you need to know that small ideas can really have big impacts on the efforts and time you need to invest. So, for instance, if you want to have an open chat, so everyone can chat with anyone in a game, independent if they are in the same game session, that would require a cross-node architecture. This is a huge effort, and you really have to think twice if that's really necessary or not. And you have to make up your minds, even if you're a game designer, about stuff like scaling, performance, and hosting. So if you have, for instance, physics on the client side, so it takes just a small percentage of the performance of the mobile device, but imagine your game is played by thousands and thousands of players, so you have thousands and thousands little physics engines running and calculating it through, so it could really kill your performance on the server side. And you need to be aware of all these effects. And when your game is a success, which is good, but then you need to scale it up and you need to be aware of how to do it. And if it's not built right into the game already or in the back end already, that could be a little bit difficult. So these are really important decisions that you have to make at the beginning, and you have you should have some experience about it. So for me, a good game design then is a perfect balance between your project goals and game features. And I think it's impossible without knowing the restrictions and possibilities of technology. So how to master it then? It sounds quite basic, but you need a really good plan. You need to set your goals straight. So you need really to ask yourself what is really important. And if you're aware of that, then you can choose a step-by-step approach. Today in mobile games, it's not a problem to push out updates, which is a good thing for both the player who gets new features and for you as well, because you can start with a basic set of important features and then elaborate on that and add new features over time. Cheating prevention, everyone says, I do not want anyone to cheat on my game, but you really need to, it's also some effort if you want to make it really, really good to prevent cheating. So you cannot prevent it 100%. If you want to prevent it 100%, you have to work all the time, because there are hackers hacking a system, then you...
They're also working all the time.
Yeah, they're also working all the time, right? They're hacking your system, then you fix it, and so on and so forth. So really make up your mind how important it is and how much cheating prevention your game needs. And then you should actually consider what tools, middleware can help you achieving your goals. So I really think it's stupid to try to reinvent the wheel all the time. So there are great tools like Unity, Apple's Game Center, OpenThing, Grease stuff, the social networks, so Box2D, Corona, there's development frameworks, Marmalade, so Papaya Mobile, social network, or SmartFox and Exozet Games Photon, which are covering then the network part for you, or helping you to build that much quicker. And one thing I really, really recommend is doing prototyping and pre-production. So that's really important, because in real-time games, I said there's a trade-off, and you have really to build a prototype in order to understand what you can achieve and what not. So the biggest issue, of course, in mobile networks especially, and in any synchronous game on any platform, is latency. So in mobile networks, you have around 100 milliseconds round-trip times, but even seconds, because there's no quality of service. And the biggest challenge are these latency jitters, so that you do not have a quite constant latency. And you can not totally, you have to work it around a little bit. So you might think about a Wi-Fi only game, so it's not necessary that your game has to be played on 3G networks, on mobile networks, so it really depends on your plans and on your goals. You have to fight the connection loss, which you have in all networks, but in mobile networks, of course, it's happening much more often, of course. And if you're doing peer-to-peer games, so based from our experience, it doesn't work reliably. So we're not 100% sure if MNOs are blocking the incoming traffic then, but it's hard to fix it. And at Exozet Games, we have many clients that change over from peer-to-peer approaches to Photon, which is a client-to-server approach. So you have to design your game around an expected latency. So you have to assume an average latency, and you have to design your game around that. You have to accept the jitter. There's no way to work around it 100%. And again, you can do prototyping, and you can simulate the latency then in your prototypes, and you can see what effects these latency have on your gameplay. So now coming to the first case study, Ping Tanks by Ping Pilots. It's an iOS game. I think I missed that on that slide. So in brief, it's a real-time multiplayer tank battle game for up to 4 players. It utilizes bird's perspective, and uses middleware, so Box2D, Photon, Exozet Games Photon is used, OpenFaint is used as social network, and it's based on a client-to-server approach. So we have a lobby server with load balancers who then directs the users to different game servers, so we can handle loads and can scale the game easily. So as you have latency, you need to think about how to compensate these effects in your gameplay, in your game. And there are many best practices out, and I can really, in the internet, and I really can recommend reading it. You can learn a lot of it, but usually you cannot just 100% take these best practices for your game. You need to adapt these to your own game. The easiest way to get around latency issues is everything is controlled by the server. So when a user does an input, it's then sent to the server, and there's no action taken on the client until the server gives this okay. So, but that feels really sluggish because it really takes some time until the user input goes to the server and back to the client. And so it may work actually on certain types of games, but for the Ping Tanks games, it didn't work. So the guys at Ping Pilots needed to take a different approach there. So one way is that the client responds instantly to an action, so something happens when you push a button or anything, like with an animation or so. But do let the server decides about critical issues. So there still can be latency bugs, but like a shot goes through an opponent, but rarely. So that's depending on the latency, how large it is then, and yeah, of the jitter effects, like I said. So on the client side, so you have the benefit that you have timestamps and positions, and you know, and if you measure the latency, then you can correct everything. So you can recalculate the position of the single tanks and of the projectiles that are firing and everything. And of course, you could, the Ping Tanks game has a slight input delay. That means it takes a little bit time until something happens. Just 20 milliseconds, so the user do not really recognize it, but the input is instantly going to the server side. So you win just 20 milliseconds, which are a lot in a real-time game. So for instance, in Ping Tanks, the tanks are moving quite slowly. So this gives you already a little bit time. So it takes some time until they start, and turning takes some time. So it's all about achieving some milliseconds to get around the latency effects a little bit. So you have animations or sounds on user input, like when player A, who's driving the blue tank there, when he hits fire, what's actually happening is that there's a muzzle flash animation. So he has an instant reaction on the client, on his input. But then the shot goes, the input goes to the server and goes back, and then the projectile will come out, not instantly. But as, of course, it's the most important goal in such a game to hit the other players, the projectiles are controlled 100% by the server. So and then based on the timestamps and positions of all the elements of the tanks and the projectiles, you can speed up the tank movement, you can increase the speed or decrease the speed, and the same with the projectiles. So how does it look then? So player A, he hits fire. The muzzle flash animation is coming, so that's a look on the server side. The server then says, okay, it's okay, he can shoot. He sends back the projectile to player A's client, and player B just some milliseconds later, 100, 200 milliseconds later, he starts his engine and drives straight forward. So you see that the position of the orange tanks are slightly different on all these clients. So that's simply because of the latency. And there could things happen like you are 100% sure that you will hit someone, but you miss it. And that's because of this position asynchronity. So, but the good thing is, as the server is controlling everything, based on timestamps and positions, everything can be put back in sync. So all the events goes to the servers. You measure the latency. You know when what event was sent, and so you can put back everything in sync again. So, of course, if you have a higher latency, then you see the positions of the tanks are getting more and more asynchronous. And you could put back that in sync as well, but it may look strange because the tanks then are moving very fast, or the shots are going much faster then. So, of course, jumping tanks look stupid, so you have to increase their speed to get them back in sync. But then you may have some rubber band effects, which look not too good. But that's only in high latency issues. And if you play the game actually on iOS, you will see that it works pretty well. One important thing also is perspective in real-time games. Many people think that ego shooters are much harder, but no, bird's eye perspective is much harder because you see any latency effect instantly. And in 3D ego perspective, latency effects are actually hidden because, I mean, if you fire at someone back there, you do not really know if you actually hit him or not. And on a bird's eye perspective, you actually see the projectiles, where they're going, and if they will hit or not. So think about that as well. And yeah.
Yeah, keeping things in sync is also an issue for mobile board games. Although we have quite a lot of more time than firing projectiles on some tanks, there are some kind of commands or decisions to be made that needs to be synchronous across all clients connected to the game. So when you think about a host and a client connection, so one is kind of the game master, and the other mobile devices connect via a server or directly to that device. There are some kind of decisions which usually should be based on the host. Think about Settlers of Catan. There's a dice to be thrown, and of course for everybody connected to that game, the same dice result should be displayed. Otherwise, people would kind of react a bit strange, I guess. And there are also moves to be performed by AI players joining the game. And there's also a set of development cards you draw from a stack. So, of course, when one player draws a card from that stack, for every other player connected to the session, the same card should be drawn from the stack. When you look at a game such as Carcassonne, which is a classical asynchronous game, there are also AI player moves that needs to be synchronized, and also, again, drawing cards from the stack. However, there's a bit of a trick that you can do. With the AI, with the tiles on Carcassonne, you basically can pre-sort the stack of the tiles before starting the game and distribute this stack in a hidden way to all players involved in the game. This way, every player is able to draw his own tile without the need to connect to the server. So that's one interesting approach. And another involving the AI players is also to kind of distribute this across players connected to a game session, because the AI player itself doesn't have any particular knowledge or needs to have a certain saved strategy, but he can decide, depending on the current game situation, what's the best move to do right now. So all those items marked directly in red color are basically independent to the clients connected to the game and can be performed in an asynchronous manner. So when we look a bit under the hood of the Catan game, there are a couple of network commands that we are using to implement or to get the different game actions across to the different players. Some are around building items such as roads, settlements, cities. Others are around transferring resources between players and also to the robber. And probably the most interesting aspect is around trading, which we'll get to it a bit later on. So just think about no multiplayer setup for Catan or of any other game. That's pretty easy to do. The user clicks on a button and says, hey, I want to build a city right here. This button communicates with an item in the game, probably a game controller, tells him, hey, build the city right here, and the game controller can immediately build the city. So it's pretty straightforward, no magic involved here. When you look at game server architecture, so you need to get this message across to other players, there's actually a different step to be involved here. In this case, we kind of serialize or encode the message to build a city in a kind of data package and distribute this through the internet, or also locally to the player itself, because exactly the same command is also performed on the client device where the player actually has built the city himself. So when you look at those arrows on the very right, this message is communicated to the other players, and at the same time the exact message is also received by the originating player and put in a kind of animation state right here, which eventually builds the city. It gets more interesting, as I said, around trading, because this is actually an activity that is performed in a kind of parallel manner. So one player decides to offer some grain for some wool, for instance, and he passes this initial offer around to the other players. So again, we would have the arrows distributing this message to the connected players. And now every player can decide to react to this initial offer. So he basically sends back to the originating player his counter offer. And this is performed in a parallel fashion, because we don't really need to wait till player 2 provides his counter offer and then player 3 gets the chance to provide his counter offer. So those connected players can actually start thinking about their counter offer and submitting this counter offer to the original player in a parallel way. So what player 1 is actually doing is to wait until all the counter offers have been received. A counter offer can also be, no, I don't want to trade with you. That's also a kind of null offer, but it also needs to be communicated to the originated player, who then eventually can choose between which offer actually suits him best. So that's a kind of interesting approach in a board game, which is usually asynchronous, like Settlers of Catan, but especially around trading, it doesn't really make sense to let the other players turn off their phones and then wake up and provide their counter offer and then turn off their phones again, because it would just stretch the usual game time to, I guess, days and weeks, and not to basically half an hour probably that a normal session would last. So as Robert also mentioned, you need to kind of be aware of not only jitter and connection loss issues, but also about players probably not reacting to your game. So there are also different ways to deal with this. One could be to employ a kind of timeout per move, or probably also a number of actions that the player can do per turn, which is just the other way around, because essentially in Catan, a human player could do a turn like forever. So he could just keep on providing trade offers to the fellow players, like hundreds, and start annoying them. So there needs to be a kind of strategic limit to the numbers of actions a user can do per turn to kind of fight misuse of this game logic from the start. You could also think about employing some kind of vote to kick or vote for ban mechanisms. So players could actually decide how to deal with players that kind of abuse the system. Although, especially with a board game, the question is how do you continue such a match? You can't, there are different ways how to replace or how to deal with a human that has either been kicked or has actually left the game. You could just abort the game, that's the easiest one. You could actually replace the player with nobody, so you basically freeze his resources and buildings he has at the moment, and he just throws the dice automatically and passes on the move to the next player. Or you could also employ an AI player in place of the human player. So that's always a tricky thing to do because it can change the usual gameplay quite in a hard way. You also might want to think about some penalty or score handling in case a player is leaving the game session. We see it in really pretty much every online game, I think, that has an online leaderboard. How are you dealing with interruptions or leaving the game just before the scoring state? Usually the players who have lost the match try to leave the game, so their score doesn't count. So especially in the mobile space, you need to find a good algorithm here, because some connections can be done on purpose by the user, but also there are lots of connection losses who would just be not on purpose, but just because of network constraints. Talking about asynchronous multiplayer, there are different ways to notify a player that it's his turn again or what has happened in the meantime. Especially the newer smartphone platforms like iPhone, Android, and Windows Phone all provide a push notification system, which is quite easy to use and should be employed for this kind of purpose. When you look at iOS, you also have the possibility to show a batch number right next to your application icon, or Windows Phone, for instance, enables you to work with a system called live tiles. So you basically exchange graphic elements on the actually larger application icons with some more background information or up-to-date information about your current matches. Of course, you could also use some notifications such as vibrate effects or sound effects, although I would recommend to use those really sparsely, or at least offer the user a possibility to turn off those effects, because it might get annoying, especially when you have, let's say, 5 to 10 asynchronous sessions going on in parallel and are sitting in a meeting and receiving like 5 notification sounds. So you should really use those sparsely. And also with the notification, keep in mind that you can have multiple ongoing matches in parallel. So you might want to think about how to present those in the best way to the user, that he doesn't get confused. Talking about communications within the game. As we mentioned earlier, in a lobby, it doesn't really make sense to work with free text chat. Whereas when we connect players who know each other, it might be good to offer also free text chat within the game. Although this has some constraints when it comes to localization. Think about players from different countries or different languages playing with each other. And it can also be misused for like advertising messages, spamming, etc. So a good way, especially on mobile, would be to use an icon-based approach, so people could basically compile their message by clicking different buttons. And especially for titles such as Catan, it makes sense to just provide a basic set of icons so players can show their emotions and also their game-specific demands, like I need wool or something like that. This kind of emotion language could also be translated into specific text snippets that are localized again by the developer to the different locales, and this way it's an elegant way, I think, to avoid any localization issues you might have with providing text or direct text input through a multiplayer session. This kind of text messages could also be linked to the actual game turn that the player does. So you could have games where the player basically thinks about his turn, and while submitting his turn, he basically attaches a text message or an emotional message to the other players, which together with his game action. Yeah, some more about cheating, I guess. Should we skip
okay.
this? Yeah, okay, right.
No problem. Yeah, so of course, in multiplayer games, people will cheat. That's for sure, that's guaranteed. And you have to, like I already said, really think about if it's really an issue for your game's success. So if it ruins the whole overall game balance, then you, of course, need to take measures to prevent cheating. So if you have chosen, for instance, to go with a peer-to-peer architecture, that's really, really hard. So you cannot securely prevent cheating in a peer-to-peer architecture because a client can always be hacked. So that's impossible. In a client-to-server world, it's much, not easier, but you can not 100% prevent cheating because the clients can be hacked all the time as well, but you can fix it then. This is an ongoing process as, clients can all the time be hacked, simulated, and there's hardly a way to really prevent it 100%. And to go just to 99%, you really have to take huge efforts and measures. But if it's ruining your gameplay and the overall experience of the players, then of course you have to go down that path. And you can also think about a mixture as alternatives. So you can have, in a card game, in a poker game, you can have a server, which is a dealer, which gives the cards to the players. So actually, there's one entity who knows about about what cards should be on the client. So if someone's actually hacking the client, then there's a mismatch between the cards that were given out by the dealer, by the game server who's residing on the game server, and the client. So you can use this mixture as an alternative pretty well as well.
So eventually there's, I guess, no way to monitor, around to monitor your game activities and take a close look at your leaderboards pretty much every day. Right. And keep on working on your titles there. Right, and talking about working on our titles, I have a little announcement here. So we are currently also developing another Catan title, which is The Rivals for Catan, the official card game adaptation for mobile devices. And we are just starting to roll out the beta for the online multiplayer right now. So if you're interested in taking an early look at the title, please feel free to fill out this application form. I think the initial one is in German, but you find an English link on the top right of the page. And we'd be happy to hear your feedback also for this title. Yeah, and from there, I think we move on to some Q&A. Right.
Yeah. So, of course, feel free to contact us with any questions you might have about multiplayer games, synchronous games, about photon technology, about development services, whatever, or just
about
ping
the
us.
Purpose of life and everything. Yeah.
Great, thanks guys. I think that was fantastic. The key thing for me is that what I hope you guys take away from this is there's complexity, there's issues, but all of the multiplayer experiences we can create can be amazing and exciting and joyful. I'm glad to say that Matthias and Robert are going to join us at Papaya and Pocket Gamer later this evening at 6 o'clock at the Turn Bar, where we're going to have a thorough discussion on the joys of multiplayer, particularly looking at real-time versus asynchronous play. So if you fancy having a drink and a debate on multiplayer, then please do. But enough of the advertising. Let's actually ask some questions. So do we have some hands in the room for questions for these guys? I have questions for them if you don't. In fact, tell you what, we have one at the back. There we go. Microphone is coming its way to you. In the meantime, obviously, please continue to use the #CasualConnect to ask us questions that we can ask any of the speakers today. Thank you.
Yeah, hello. Good. One question. How you prevent cheating with friends? Because I see with Words with Friends, so that's not a big problem because it's pretty simple. But when you play with friends, when someone sets up a custom game, how you prevent that they just like always let one guy win to like gain a bit better win-loss ratio or something like that?
Yeah, I think it's primarily a question how you handle the leaderboard ranking. So if you employ an ELO-based ranking, which is kind of similar to what the chess or the tennis world leaderboards are using, you don't gain so much of an advantage when just playing against the same players over and over again. But to gain some additional score, you also need to beat players much higher up the leaderboard to actually gain an insignificant advantage. Another way would be to not count in those custom games to the official online leaderboard at all. So you basically only count in matches that are really skill-based matches with other players, and only those are counted to the online leaderboards. Eventually, when cheating in a custom game, you only cheat yourself then. Yeah.
Cool, thank you. More questions? Well, let me ask one. So one of the things in my mind that's always an issue, I think, Robert, you mentioned this about the latency jitters and all that. I think you made a comment about think about Wi-Fi only. Isn't that really a question of a game design choice? I would argue that there are plenty of opportunities for creating really good real-time and asynchronous games, and part of the design process should take into account the technology. Is that fair, or do you have any comments on that?
Absolutely, 100% agree. It absolutely depends on what you're planning, what target audiences you want to reach, what are your goals you want to reach with a game. And of course, thanks for mentioning it. It's much more fun playing multiplayer games, I think, especially on mobiles as well. And so it is just a matter of the game design, and if you do it pretty well, like in the Ping Tanks game, it works great in mobile networks as well. So that's just, maybe you can choose a step-by-step approach and go with the Wi-Fi version first, and then introduce 3G networks as well as an option. So that's really upon your goals, I think.
Matthias, do you have any thoughts on it?
Yeah, I completely agree. I think in our case, our titles are not so much dependent on those network jitters, but those really hardcore synchronous games, such as car racing games or shooters, those definitely need to deal with those.
So let's move on to another question then, because one of the other things in my mind is an issue that affected us back in the days of Wireplay, and services like Pogo and various others also had the same problems around sort of 99, 2000 era. That point, I think you were talking about, of people dropping out of games. Is this a significant problem? Is it something that we can deal with using other sort of social metrics? Is it possible to create a kind of sense of shame, if you like, for having failed to complete a game? Is that something that's worth doing, or would we simply alienate users if we did that?
I mean, you could think about a certain trophy when you drop out like 10 times out of a game or so.
Yeah, exactly.
But I'm not sure if that's really helping in that regard.
The quitter badge. Right. Do you think we should have a quitter badge, for example?
Yeah, maybe. When you also look at asynchronous multiplayer games, there's not really so much of an issue with dropping out, but that's more about what's the maximum time you allow per turn. So, yeah. You don't have those technical issues anymore, but more the actual user time when he needs to spend on the game, or he needs to get back to the game.
Yeah, I think the problem is that people can always create fake accounts and can use this. So it's a good idea to have this bad trophy if you drop out too much, for sure. And if you're somehow exposed to the whole community, shame on these guys. So the most dropout leaderboard would be a nice idea, of course. But like I said, you can always create these fake accounts, and you cannot prevent it 100%. That's a great idea to have.
Cool. Okay. So let's see if we can get one more question in. I mean, is there anyone in the room who is already making a real-time or an asynchronous multiplayer game? Okay, so we've got a couple of... Well, you know, we've got... interesting having, you know, Days of Wonder here and, you know, Exozet, two guys who are really interested in board games online. So let's... can we ask you, sir, Jan, you know, do you have any particular views? Is it that the board game is a particularly good format for real, you know, multiplayer gameplay, do you think? Would you say? Well, hopefully we can get a mic to you as well.
Thank you. Hi. Yes, I agree. Board games are really, really nice for multiplayer games, especially since most of them are turn-based. So it covers, it addresses a lot of the difficulties that you guys mentioned about the problem with latency and so on. And I agree with everything that was said about the cheating issues and the solutions and so that, definitely.
Thanks. So, last chance before we call it quits. Any more bursting issues or questions? Cool. Okay, guys, thanks very much. We're back here at 1 o'clock. Obviously, please feel free to continue to use #CasualConnect as your tweets. I'm paying attention in case there are questions for the various audiences. See you all at 1 o'clock. Thanks very much.